right, my friends, we're here to talk about cloud native innovations today. Be sure to ask your questions in the chat, and Mark will answer them as we wrap up. I understand you've been doing cloud native since 𝗦𝗽𝗀𝗀𝗀, you know, the early Egyptian dynasty. Is that true?
Not quite.
Oh, well, close enough, right? You've been here since the beginning of Azure. How has everything sort of grown up? Tell us about that.
Well, when I started in Azure, I was asked to do a presentation at one of the Azure All Hands, and it was over in Building 92 on campus, so it's a conference center type building, and it was in one of the large rooms. And that was everybody in Azure, which meant everybody in the world that knew anything about Azure at the time, including at Microsoft. So it's grown a lot in terms of both the people that are supporting Azure. It's a huge part of the company focusing on Azure, and then the infrastructure, of course. We went from launching back then, when Azure started, it was like 30,000 servers or 40,000 servers. Now we've got millions and millions.
Now it's more.
Yeah, it's a little more. Yeah.
How has the architecture changed over time, and how have people started using the clouds in innovative ways?
I think one of the biggest changes to the architecture has been the rise of containers.
Yeah.
And that sort of started happening. Containers have been around for a while, but really started to adopt it in Azure in the 2015, 2016 timeframe. That's when it really went mainstream. And so that has changed the way that we architect, going from monolithic kind of big chunks for microservices to fine-grained containerized chunks. Really an evolution of Service Fabric, which we've talked about before, which is the underlying a lot of the Azure Foundation, which is still there powering the foundation of Azure.
So there's been a lot of projects that you've sort of incubated over in the CTO's office, Azure CTO's office. Can you tell us about those and what they are and where people can find them?
Yeah, so I have an incubations team which kind of grew organically because I had technical assistants that would help me with research and presentations, doing some of the legwork on that. Turns out that they were really creative, and they came up with some ideas that, in the context of what I was looking for in terms of evolving cloud-native applications 5, 6 years ago, were right at the right time. So 2 problems we saw were, one, how do you make it easy for enterprise developers to write distributed, resilient, microservice-based, containerized applications? And then how do you describe those applications? How do you scale this application? So the incubations that came out of that team, the first one was 𝗬𝗲𝗏, which is the Kubernetes Event-Driven Autoscaler, which was just graduated in CNCF as a graduated project.
That's cool.
In August. In August. The second one was 𝗬𝗲𝗏, the Distributed Application Runtime. And that one is an incubating project that was just submitted for graduation in CNCF. And then a third one, which we've just submitted to CNCF, was 𝗬𝗏𝗀𝗃, which is a container patching system. So for patching containers for security vulnerabilities.
So help me understand the difference here, because the 𝗬𝗏𝗀𝗃 is the new one that I've heard of 𝗬𝗲𝗏. We'll get into that one a little bit. 𝗬𝗏𝗏 I haven't heard a lot about, but 𝗬𝗏𝗀𝗃 sounds interesting. What do you mean patching containers?
Yeah,
that seems interesting.
It's kind of interesting because when I was looking at the adoption of containers, like I mentioned, containers everywhere, and the way that containers are built is with something called images, where the images are built up in layers, and one image layer depends on the layer beneath it. And if you want to patch, if you got a vulnerability in, let's say, 5 layers beneath your application, you need to wait for whoever created that image to patch that image, distribute it to all the container registries, kick off, the next layer needs to kick off their pipeline of build to rebuild their image that depends on it, and so on. And you end up with this waiting 5 levels. And if somebody is taking a long time to patch,
just hanging out there with a vulnerability.
You're stuck. There's nothing you can do. So the idea behind 𝗬𝗏𝗃 is just basically like traditional, non-containerized software patching. Can you patch those layers? And that way you can do a targeted patch and everybody gets the vulnerability fix without having to rebuild that entire stack.
So here's a question, because I've done stuff with containers. It always seems to take a little bit of time. Is patching a fast thing? Tell us about that.
Yeah, well, patching is simply inserting a patch layer on top of the layers. So let's say you've got a vulnerability in OpenSSL at the very bottom in your distro. You take the patch for OpenSSL and insert that as a layer
In between the other ones.
Yeah, in between the other ones. And so everybody sees the OpenSSL fix. They don't see the vulnerable image underneath.
And I bet that's way faster.
I mean, it's basically instant, and it's very small, you can have targeted fixes. So we've actually just put this into production in Azure and Azure Machine Learning.
Yeah.
Patch the images in our own infrastructure, which some of these images, some of these ML images have, hundreds and hundreds of packages in them.
True.
And so they'll have 1,000 vulnerabilities. And this thing will come in and copacetic and patch them all without having to rebuild everything.
That's a good name, too. I just realized. So that everything can be
copacetic. Yeah.
These are the jokes, people. Yeah. Come on. That's awesome. So 𝗬𝗲 and 𝗬𝗲, quickly about those. 𝗬𝗲, what is it supposed to do?
So 𝗬𝗲, the idea of what the genesis of 𝗬𝗲 was looking at auto-scaling on Kubernetes and not seeing anything that would allow you to actually scale down to 0 containers.
Okay.
And so 𝗬𝗀𝗀𝗀𝗃, who went on and helped create Dapr and now has a Dapr startup called Diagrid, he was like, I've got an idea for creating an autoscaler that can scale to 0. And so he implemented that and then also made it an extensible autoscaler in the sense that you can plug in arbitrary metrics with rules for autoscaling. So you can plug in, HTTP load, number of events, whatever kind of arbitrary kind of load measure you've got can plug into 𝗬𝗲 and allow it to autoscale. And so the first thing we did was graduate that out of incubations into the developer division.
Yeah.
And so they've integrated it into Azure Container Apps.
Yeah.
It's now also an add-on for Azure Kubernetes Service. Mm-hmm. And so and like I said, it's gone into CNCF. It's really become the de facto autoscaler for Kubernetes.
And that's cool, because I always think, like, well, it's got to be easy to scale to 0. And I'm just like, wait a minute. If there's no process to see, so this is a really good, and then Dapr, obviously, a way to minimize or to take away all the boilerplate. Tell us how it does it.
So the idea with Dapr is looking at the different programming models that enterprise developers were looking at for cloud native at the time. You had event-driven kind of functions. You had long-running microservices. You had actor model for stateful microservices. But they all were very vertical. The language integration into the runtime and the platform around it was unique to every type of, if I go use this library, now I can use these capabilities. And I've kind of bought into the whole thing. So the idea with Dapr was, let's create an API surface of building blocks with different purposes. Like one is events that you can get, like triggers. Another one is bindings for integrating with external services. Another one is service invocation, so calling another service. And make these building blocks composable a la carte and offer them through a sidecar. So an API that is sitting in a container outside of your own app that you just call. And what you get out of that is an abstraction where you can abstract the underlying implementation, which in Dapr are called components. So for example, for PubSub, one of the most popular building blocks is like, I want to send messages between my microservices or to external entity. I can leverage the Dapr API for PubSub, and that building block then at deployment time, I can plug in with my implementation of PubSub that I want, whether it's event hubs or whether it's Kinesis on AWS. And so the idea is it's an abstract API. Developers don't have to worry about authentication. They don't have to worry about retry. They don't have to put SDKs into their code. They get portability off just for free. They get monitoring for free because Dapr's instrumented with 𝗬𝗲𝗀𝗀𝗃, so you get instrumentation just for anything you do with Dapr, you get it. So it's really kind of, I view it as the cloud operating system API. And
that's cool because there's so much boring code that we have to write to support that. It's better just to use the building blocks.
Yep.
All right, so the last project I want to ask you about is Radius. Tell us about that and what's new here.
So Radius, so Dapr is a programming model. It's how you write the code. The idea for Radius is the same thing, except for how you describe the application. So if you take a look at Kubernetes as a platform for containerized applications, it really doesn't separate an application from the infrastructure. And what I've seen is enterprises struggle with the complexity of Kubernetes, and enterprise devs obviously overwhelmed with just getting their app written and not wanting to have to learn everything about Kubernetes, not just Kubernetes, but the fact that they've got to learn all these other SDKs and describe all the other resources the app uses. And So what if the idea was, can we create an application definition that is abstracted from the underlying infrastructure in a similar way that Dapper APIs are,
Okay.
that allows a developer to describe their application and then deploy it to an infrastructure where that connection between the app and the infrastructure is handled through some mechanism that says, oh, you want to have containers that scale like this. This is the way that we program Kubernetes to do that. You want a pub sub. We'll automatically set up the pub sub configuration for you and authentication for you. So platform engineering has emerged as the way that IT operators set up environments for their devs to use that are compliant and secure. And this separation allows them to go create those environments or landing zones. And so you get a full view of what an app is. You get portability because you can go to any Kubernetes-based system. And you get this separation between the app and the infrastructure that a platform engineering team can go and connect that binding for.
So I had to do a Kubernetes thing, more like a Kubernetes, because it was just what...
Horrible joke.
It's the dumbest thing I've said today. He's like, no, that's not the dumbest thing you said today. We've had a chat before. I had to do it. But there was like a YAML file that described the application and the containers. How is Radius different than that? Because I think when you were saying it, it's more than that.
It's more than that. So we started with 𝗏𝗲 as the primary language for describing Radius applications. So you describe the application and the pieces of the application, and that includes both the containers, the compute part of it, as well as the cloud resources that you want to use.
Right.
And we, like I said, we started with 𝗏𝗲, but we also added support for you to be able to integrate Radius into Helm charts. So if you want to use YAML and Helm, you can do that.
So it's like not just the containers that are running and the state, it's all the services that they're actually using as well.
And Radius knows about the connections between all of them and can do that orchestration.
Oh, that's nice. So you have a demo of this, right? So can we get that queued up here so you can show us what's going on? Let's see, where is it? Okay, here we go. So what are we looking at?
So what we're looking at here is a 𝗏𝗲 file that describes an application. And you can see when we zoom in here that there's a 𝗏𝗲 resource for the application, that those resources that the application depends on are connected to.
I see.
So you can see a bunch of resources there. Now, this is actually an application called 𝗏𝗲, which is a Microsoft reference application. Containerized, has like 12 microservices. You can see here as we're clicking open some of the properties that from an application developer perspective, you don't see any infrastructure here. You see them referencing, hey, I need a Redis cache, for example. They're not specifying details of the Redis cache, like I need an Azure Redis cache, and it needs to be like this. That's something for the platform engineers to worry about. So this is where the developer sees it. Now, because if you have this level of abstraction, I've got 3 environments here, or recipes, for binding the application to a Kubernetes local environment. Here you can see in the middle, it's an Azure environment. There you can see Azure Redis. And then the right side, you can see it's AWS. So 𝗏𝗏, the application description, containerized, I'm just deploying it here now to those 3 different environments, kicking that off. And what we'll have is a deployment of 𝗏𝗏 without modifying the application definition that you just saw, native on Kubernetes locally, native on Azure, and native on AWS. And there's the deployments kicking off there. You can see the resources being created. And now I'm going to switch over to the portal views. There's a local portal for Kubernetes cluster. There's Azure, native resources. There you can see SQL databases and Redis caches. And then you can see AWS there. You can see that the managed AWS offering there. And then we can click and look at the UXs, and it's the same UX on all 3.
Is that you in the picture, Mark?
Yeah, I used to model.
Oh, yeah, nice.
𝗏𝗏.
Yeah, that's true, of course. We were both 𝗏𝗏 employees.
For 𝗏𝗏𝗀𝗀𝗀.
Yeah, 𝗏𝗏𝗀𝗀𝗀, that's what we do.
Yeah.
This is pretty cool. And the thing about this is, if you didn't watch the keynote, I made that demo, and it's a lot of setting stuff up.
Yeah.
And I could have just written this and pushed the button.
You could have. And actually, we took 𝗏𝗏. When we started with 𝗏𝗏, it was like scripts, bash scripts, PowerShell scripts, YAML files.
That's what I had.
Charts,
that's what I had.
Kubernetes YAML and Helm charts, like thousands of lines. And with Radius and 𝗏𝗏, we took it down. It's like the 𝗏𝗏 description of the application is like 200 lines of 𝗏𝗏.
Well,
and you get these benefits. So,
I worked too hard I should have just called you and been like, hey, show me this Radius stuff. Yeah. Where can people find out more about this?
So radapp.io is where you can go, and then you can find the link to the GitHub repo there. It's open source. We've just submitted to CNCF as well. So, and we support, as you see, AWS, Kubernetes, and Azure, and we're going to be adding GCP soon because many of our enterprise customers are across multiple clouds. And welcome contributions. And by the way, it supports Terraform recipes. So you can leverage your Terraform modules as part of that, creating that infrastructure underneath. It supports Helm chart integration. So I think it's really got a lot of value, and we're looking forward to having people contribute. And
I think there's a session, too, on Friday.
There's a session, and this is exciting. I'm doing a session with Brendan Burns, who a lot of people know as one of the co-creators of Kubernetes.
Yeah.
He and I are doing a session with some people from the incubations team tomorrow that will show off Radius and talk more deeply about it.
That's cool. Okay, so I want to move on to something else because, like I said, I made this demo that I did for the keynote. Maybe you saw it. It actually used Azure Container Apps. And while I was, spelunking around, I noticed that I had a lot of choices when it came to doing containerization. I had Azure Container Instance, is that what it's called?
Yep.
Azure Container Apps, and Azure Kubernetes Service. So ACI, ACA, AKS. Can you help me understand maybe what I should have chosen or what people should choose? When and why and how?
Yeah, so ACI is our fundamental serverless container offering. So it's a primitive kind of unopinionated, here's a serverless container.
Yeah.
That actually supports integration with AKS that I'd like to talk to you about here in a second. But ACA, Azure Container Apps, is an opinionated microservice application model. So it's really kind of provides you an app model, again, without worrying about the infrastructure underneath,
right,
for describing a microservice-based containerized application. So it comes with Kata built into it. It comes with auto-scaling rules built into it, and the way you describe upgrades for blue-green upgrades and rolling upgrades. It handles that kind of orchestrations that you'd normally have to go to Kubernetes to get, but you can get in a serverless kind of form factor with ACA. And then there's AKS, which is obviously managed Kubernetes. So if you really want Kubernetes in the ecosystem of Kubernetes capabilities and Helm charts and everything that comes with that, then AKS is there for you.
So it feels like ACI is like if you just have a container and you want to run it, just put it in, just do that.
Yep.
That's the easiest thing. If you want to start having a more opinionated approach to containers, et cetera, and this is the question I want to ask, when it comes to using like Dapper and the other things like Radius, et cetera, when do you start? Is that at ACA forward? Is that what I'm getting at?
Yeah, so Dapper is being integrated into ACI right now. In fact, that's an announcement.
Oh, really?
So if you want a Dapper sidecars and Dapper's managed support for ACI, that's available now. It's been from the start in part of Azure Container Apps.
Okay.
So Dapper also graduated like Kata into developer division, and they've been integrating it into their various services. What you're going to see is basically Kata and Dapper everywhere in all our compute services, just as that common base layer of capability. But so, yeah, as far as answer your question about Dapper, it's there wherever you want it as far as those containerized services. And as far as Radius, hopefully we'll get there too. Need to prove it out, and then we'll see about having it integrated into our products.
And that's cool because, like I said, the thing that I found nice about ACA is I wrote it was like a Next.js application. I didn't realize that React was much harder than advanced AI, which is what I generally do. It's really hard. I noticed that if I put into a container, there was some really easy AZ CLI things to just push it up. It managed the secrets for me. But I could have done more with something like Dapper, right?
Yeah.
Like, what things should I have been doing that would have been better, like if people are listening? Well,
I think the thing with Dapper is instead of calling cloud services directly, use Dapper building blocks to leverage that.
I see.
And instead of writing your own way to invoke another microservice or another part of your application, use Dapper service-to-service invocation or pub sub. And again, you won't have to worry about authentication. You won't have to worry about backoffs and retries and resiliency. You won't have to worry. You'll get portability if that matters to you. It might not matter in your case, but because you're an Azure aficionado.
You know what? Thanks for telling me this now. I could have used this information a couple of weeks ago. Hopefully some of you all will be able to use this. Final words, thoughts?
Just a bunch of great announcements for cloud-native computing, and I'm really excited about Radius. It's kind of fitting the puzzle. Radius and Dapper integrate well together, so you can have Dapper resources in your Radius app description, and it'll handle the configuration of those Dapper components.
Well, I learned a little bit here today. Thank you. I should have used Radius, a little bit more dapper. Thank you so much, my friend. All great news, exciting stuff. Remember, if you missed some of this conversation, it will be available on demand after the event wraps. All right, that does it. Thanks for joining me, Mark.
Thanks, Seth.